Hi everyone. We're moving on now to a lesson 4 about the periodic table. And the first thing I want to say about this is please have your periodic table in front of you. And number 2, I want to make this very clear. I'm going to be talking about some patterns in this lesson. And this is an example of where I want you to be familiar with the patterns that I'm saying or the areas of the table that I'm talking about. But I want to be clear, I'm not explaining necessarily why right now, and that is to come. So when you're watching this video and I say we have a certain group here or a certain pattern, you might be saying to yourself, well, why is that? The why is coming. Right now, I want you to be familiar with some of the things that I'm talking about. So please have your periodic table in front of you. To begin, the periodic table, that is your periodic table of the elements. Okay, you can read this slide here. There's about 90 that occur in nature and 25 that can be created in a lab or under very, very extreme conditions. Your periodic table is going to be divided into 3 sections. You're going to have the metals, non-metals, and metalloids. And metalloids, we're not going to cover too much here. Just be familiar with where they're found on your periodic table. Perhaps you can find that already. Now, sorry for the writing there. Now, this is kind of your general flow. The elements. Now, what you can see is I want you to be generally aware of where the metals are found. Generally speaking, they're towards the left-hand side, and they're red. Here are some general characteristics. They are silver or gray and shiny. They are good conductors of electricity and heat. That's very important. They are malleable and ductile, which we learned about previously. Most are solid at room temperature, and most react strongly with other substances. These are just general properties, but important here where are they found? Generally towards the left. Okay. Then you might notice, and this is kind of where I had erased, but if you look right here on your periodic table, you'll see it. There's kind of a solid black line, and that is generally known as a staircase line, and that's kind of your divider. It separates, in general, your metal from your non-metals, okay? If we move along, then we have non-metals. And what I want you to notice here is what we have, there are 17 elements or non-metals. Some are highly reactive. What I want you to know here is a couple of things. First of all, where are they found? Well, the give or take towards the right. What you might notice is that there's a blue all the way to the left, and that's hydrogen. I want you to be aware of that. I'm not explaining why right now, but I will. But generally speaking, non-metals are found all the way to the right on your periodic table. Okay? Be aware of that. Now, the next thing I want you to be aware about, I'm not explaining why. I'm not even telling you why it's important right now. But there are certain non-metals that come in diatomic or polyatomic forms. What that means is they exist in weird groups. And what I mean is, you know that you're breathing in oxygen right now. But the oxygen you're breathing in, it's a molecule, it's a group of 2, okay? If you could look at one molecule of sulfur, it's actually 8 sulfur atoms put together. They come in these various groupings where it's not one single atom. They come in groups. So nitrogen comes in a group of 2, oxygen, hydrogen, so on. Phosphorus is a group of 4, sulfur is a group of 8. And what I'm going to have you do, if we move ahead a page, I'd like if you could somehow put a little bit of some markings here on your periodic table. And what I mean by that is simply this. If I zoom in, I'll pause here. You see, over on this side, you can see nitrogen, oxygen, fluorine, chlorine. You get the pattern. I have some red marks. The red mark means that they exist in diatomic form or groups of 2. The other diatomic is over here on the left, and that's hydrogen. Okay? Furthermore, if you look, you'll look at phosphorus. I put blue there because phosphorus exists as P4, and sulfur always comes as an 8. Okay, so if it's red, they come in groups of 2. If it's blue, it comes in a group of 4. And if it's sulfur, it comes as a group of 8. I know quite clearly, everyone, I have not explained to you why that's even important. But believe me, it will be when we come to reactions, okay? Oh, and while I'm here, everyone, I do want to point out, remember, there is that solid black line, your staircase line, and that is going to separate, in general, your metals and your non-metals. Now, let's move forward. Let's look at some more properties of the periodic table. The periodic table organizes all elements according to their chemical properties. Metals are on the left and center. Non-metals are on the right, metalloids in between the two. Hydrogen is an exception. In short, hydrogen can behave as a metal and a non-metal. And you will learn why. That's going to be because of the 288 rule, which we haven't learned yet. But if you're thinking about it, that does sound familiar to the energy levels of the electrons that was kind of discovered via Niels Bohr. Does that come back from the last lesson to you? Most of the elements are represented by a symbol abbreviated from their name. Example, carbon gets a C. A lot of people then would assume that lead would be L. That's not always the case. Sometimes they'll have a very odd symbol, like lead is PB. Okay? But over time, when you first start and someone says find an element, you might be looking around for a while. But over time, you'll come to find them very, very quickly. Now, this is important. The periodic table is further broken down into rows and columns. You see, the horizontal rows are called periods. The first horizontal row is row 1, row 2, period 1, period 2, period 3, going this way. And then, of course, you have groups, which are your vertical columns, and they go from 1 to 18. Now, over here, I did put this in. There are some reasons as to why, but we'll come to that soon enough. But I want you to know, vertically, those are your groups. Horizontally are your periods. And it has been put together in a very specific way. Basically what's happening here, everyone, is everything's related. And this thing wasn't just put together in a random fashion. They've been put into horizontal periods for a reason. They've been put into vertical columns for a reason. And what I have linked to this section of the workspace, there's a Khan Academy link down there. I'd love for you to look at that, and it'll delve into this further. There are 4 specific groups I would like you to know. All the way to the left, those are your alkali metals, lithium, sodium, potassium, and so on. So they are alkali metals. Yes, you have to know this. They're all the way on the left of your table. They all have a charge of +1. We will discover why. It does have to do with this 288 rule. They are very reactive. Soft, shiny color, tend to be white solids. If you go one more group to the right, you have your alkaline earth metals. Yes, you have to know this. They all have a charge of +2, and we will come to understand, again, based on this thing called the 288 rule. They react slightly slower. We'll understand why that is too. Shiny and silver, but not as soft as alkali metals. If we shift now all the way to the other side of the periodic table, you will have 2 more groups. You have your halogens. They are group 17. They all have a charge of -1, and the 288 rule will tell us why. They react quickly. They are poisonous. They do react quickly on the alkali metals with various other elements such as sodium. We'll figure out why. Noble gases all the way to the right. They are group 18. They have no charge and they're unreactive. And guess what? The 288 rule will tell us why. You are familiar with this actually in your day-to-day life. Helium balloons. You've used helium before. Neon signs, like an open sign. So you see, the thing is here, everyone, what I've broken down for you are some general characteristics of the periodic table. I've told you about some groups. I've told you about some diatomics, or these groups of nonmetals. I've told you about periods and groups. General understanding that I want you to know. And take my word for it, I will explain to you why coming up. But let me be clear, there is, in this section of the workspace, underneath where you find this video, there is a link to a Khan Academy site. And I'd love for you to go through that, and it goes through the periodic table even more. Okay, let's move on.